Now let's try working on the second question. Two cars start at the same point and travel in the same direction. So let's say this is the first car and that's the second car. The first car traveling at 60 miles per hour, 2 hours earlier than the second car. So suppose the second car travel for t hours, then the first car will be 2 hours more because the first car starts 2 hours earlier than the second car. Now, the second car travels at 90 miles per hour. How long does it take the second car to catch the first car? Now, you see that again, the first car travel earlier but slower speed, while the second car start traveling 2 hours later after the first car, yet because it is traveling at higher speed, then we do expect the second car will catch up with the first one. Okay, now then let's say we start with the four-step method. Let t be the time the second car needs to catch the first car. Okay, now that implies the first car at that time has been traveling for 2 hours more than t, which is t plus 2. Now, the second thing we will do, we will try to do the table. This is car number 1, car number 2, that's the time, the rate or the speed, and this is the distance traveled during that time. Now, from our definition here, the t is the time the second car needs to catch the first car. And because the second car traveled 2 hours after the first car starts, then the first car must have traveled for 2 more hours compared to the second car. Now, the rate of the first car, as given by the question, is 60 miles per hour, and the rate of the second car is 90. Now, therefore, the distance will be the product of the time times the rate. 60 times t plus 2 for the first car, and 90 times t for the second car. Now, the thing is, the question here asks, how long does it take the second car to catch the first car? Which means, by the time the second car catch the first car, they should have traveled the same distance. Now, because they have the same distance, that's what we will do. We will set them equal to each other. 60t plus 2, that's the distance traveled by the first car when the first car gets caught by the second car, and that should be equals to the distance traveled by the second car. From here we then solve it. 60t plus 120, I basically do the distribution, and 120 equals to 90t minus 60t, 30t equals to 120, therefore the t equals to 4. Now this implies it takes 4 hours for the second car to catch the first car. Now, we are done with this question, but let me go on a little bit further. At times, the question is indeed not how long it takes the second car to catch the first car, but instead, how far has the first car traveled or the second car traveled when they meet. Now, if you have that kind of question, the way you do it will be actually the same. You find the time first, and then from there you plug this time into the distance. Okay, now notice that at this time they already travel at the same distance, then you can actually plug this t into either one of them. Okay, that way if you think about this, when will the second car, at what distance the second car catch the first car? 4 times 90, 360 miles from the originating point. Okay, that's for number 28 and some possible variation of that.